Hey engineering folks, it's Ms. Haynes. Welcome to second quarter. The first thing we're going to do is we're going to start going through some IED CAD basics. We're going to start talking about, in this section, how to use the hole feature and how to annotate holes in schematic drawings. So, engineers must communicate the details of the way objects are made and assembled. So, if you're going to talk to anybody who's manufacturing, if you're going to talk to anybody who's putting anything together, they need to know how to put it together. They need to know what the features are, and an important feature often is what kind of holes and what kind of fasteners are going to need to put things together. There's 3 types of holes. You got simple holes. It's just straight through. There's nothing except, it's like you take a circle and extrude it, that kind of hole. That's a simple hole. That's for if you have like a pin or a peg you're going to put in and fasten it together. And then there's a counter bore, and that's got a second little feature to it. Where's my mouse? You can see sort of it's got like a second hole drilled near the top of it, and it's got a flat bottom to that extra piece. And then there's a countersink, and that's got this sort of angled piece. And so you'll see sometimes if you're putting together furniture, if you have a bolt or something and they don't want the head of the bolt to be sticking out, they'll have this counter bore so it'll sink in and it won't stick out past that level of the wood or the metal, whatever material you've got. This one here with the angle, a lot of the time wood screws have that sort of angle underneath the head of the screw, and so that helps it sit more flush with the material. And there's two different classifications too. You can have a hole that goes all the way through your material, or you can have a hole that's called blind. You may recognize the word blind from what we do in CAD. If you do an extrusion or anything, the automatic setting usually is blind. And that, in this case, like if I have a hole that goes all the way through, like this one here on the left, you'll be able to see. If you turn it over, you'll see that the hole comes all the way through. But right here, inside the material, you're not able to see from the outside of that material where those holes end. That's why it's called blind. You'll notice over here in the drawing, they've got, basically they've got a slice out of it so you can see the different kinds of holes and you can see the cross section. And so this part down here in each of these images, that's got a cross section view. That's like take a slice, a section view. And if you notice, there's these diagonal lines, and that's basically saying, hey, this is the material that I've actually had to cut through for you to be able to see these features on the inside. So the other thing you'll see is these center lines. It's like a long part, a little short dash, and a rather long part. Those are center lines to tell you where those center points are. So 3 types of holes. Simple, it's just like a cylinder extruded through. Counter bore, it's a cylinder with another little cylinder on top that's a little bit wider. And countersink, that's like a cylinder with basically a cone upside down on the top of it there, taken out. Alright, and the type of hole depends on the type of hardware you're going to want to use. So here's some notations. We're going to talk about notation real quick, and you guys are lucky because you're not having to look at it across the room. When I put this up on the big screen, I was like, wow, these are really tiny words. This circle, the line through it, that's not an empty set, that's not a zero or a null. That is standing for diameter. So if you're telling any information on your paper about the diameter of the hole or the diameter of the counterbore countersink feature at the top, you're going to use a circle with a line through it to say that's a diameter. If you're putting these hole notes together and you've got a depth, you need to notate that we have a number that's associated with the depth. Then we're going to take this line with the arrow coming down through it. And then the 2 types of holes that are not simple, they're going to have extra features you're going to have to notate. And so the countersink is going to have this sort of a V shape, and the counterbore is going to have kind of the top of a field goal shape to it. Okay? So here's an example of counterbore notation. If you're going to do a counterbore, let me go up to the picture of it. If you're actually going to drill out a counterbore, usually what you do first is you drill out that skinnier one, the one that goes, the longer part of it that's got a smaller radius, and then you go back and you drill the larger radius part into the top right there. So you start by cutting a 0.375 inch diameter hole. If you look at here, this is all this is just sort of like a paragraph I wrote based on these notes right here. You'll see that there are two places where it's measured across, and this one here measures the diameter across the majority of the hole as it goes down. That's 3/8 of an inch. This one across the top here, that measures the top of the bore feature. And these two vertical measurements, they tell you depths. So this depth right here, down to the bottom of the hole, is 2 inches, and the depth of the bore feature is 1/2 inch. Now, this guy down here, I think that's probably standard. Anytime you drill a hole that doesn't go all the way through, you're going to wind up, if you're drilling it, you're going to have like a drill bit, and the drill bit's got a point on it, so you're going to have automatically a little bit of a pointy tip to it anywhere if you do a blind hole. I think 118 degrees is kind of standard. I've not really seen a lot of notation about that. That part's not ever notated when you do your notation. The parts that are is the diameter of the main part of the hole, the depth of the main part of the hole, what type of a hole it is, then the diameter of if there's a second feature, and the depth of the second feature. So over here you'll see, this is the way the first line should look just about any time. You're going to have a diameter symbol, you're going to have the diameter of the main part of the hole, then you're going to say something about the depth of it. In this case, it goes down 2 inches, that's blind, it's a complete measurement. You're going to use this depth symbol, and then you come with the depth right there. You'll notice there's no units over here on the right side. That's because if you were to actually make this whole drawing, like in the industry, you'd say, okay, all the measurements on this paper are in inches, so you don't have to write inches after every single one. If this had gone all the way through, instead of this symbol and this number, you just write through, all caps THRU. If you're annoyed by that, I am as well. It's just the way it is. It's something that I learned when I was first going through all this too. Alright, so this guy's not just a simple hole. It's got this extra feature at the top. It's got a bore, so we're going to use the bore symbol, counter bore. Looks like a field goal, and it's kind of helpful because it's the same shape as its cross section right here. So we got to tell the diameter of this guy. That's 3/4 of an inch. Diameter is 3/4 of an inch. And the depth right here is 1/2 inch, so we got to tell the depth is 1/2 inch. All of your information is in that notation. And so you can use that notation. That'll be put next to your hole in your drawing, or if you make a sketch, you can write it all in there by hand. For countersink, it's slightly different. Countersink, just like counterbore, you're going to start with the diameter of the main part of the hole. In this case, the diameter here says 1/4 inch. So you're going to do the diameter symbol, 1/4 inch. Then the depth, you're going to look at the depth of the main part here, and that is 2.25, 2.25 inches. So you make the depth symbol, and you put 2.25. You look at it, you say, okay, have I got another feature at the top? I do. It looks like a countersink. It's got that V shape to it, so you draw the V shape here. The diameter across the top, the widest part of that V shape, is 1 inch. So diameter 1.00. And then they have this X, I think it's read by, like your diameter is 1 inch and it's by 82 degrees. That 82 degrees refers to the angle here in the center, from side to side. 82 degrees. Okay, so what it says is, hey, I've got a hole I'm going to drill with a diameter of 1/4 inch, and that's going to go down 2.25 inches, and then I'm going to add a countersink feature with a diameter of 1 inch at the surface, and it's going to have an 82 degree angle in the center. So here's just an example of what it looks like when it's on a drawing. I took this out of the PL2W site, and this part on the right here with the yellow, that was the first part. And so you can see there's a hole right here. Each of these is going to point down to the hole that it's talking about. This one says a diameter of 1/2 inch through. That's a simple hole. You notice there's no second line, it's just one line. Diameter, depth. 1/2 inch through. It goes all the way through it. This information is from the counterbore a couple slides ago. I got a diameter of 3/8 of an inch, depth of 2 inches. And that's the main part, and that's that central part right there. You see, a depth of 2 inches did not go all the way through. This feature is 3 inches tall, so it doesn't go all the way through. And then I've got to add the feature that's counterbore with a diameter of 3/4 of an inch. That's this top part here and the outer part. And the depth is 1/2 inch. So down, this is only 1/2 inch in right here, this donut shape here. And hey, look at this, that countersink, that's the last slide we saw. The main part of the hole is 1/4 inch in diameter. So that's that center piece that goes down 2 1/4 inches. Then it's got this sort of upside down cone feature going into it. It's got the countersink with a diameter of 1 inch around the outside here. And it goes at 82 degrees in the very center. This guy here, that's a 1/2 inch through. So this is a 1/2 inch through, that's that middle part right there. Then it's got a counterbore feature put on that's 3/4 of an inch that goes down for, it looks like 5/8 of an inch. So this guy right here, around the outside, it's got a ledge around the outside like that. You'll notice they also dimensioned this thing is 2 inches wide, and the centers of all the holes are 1 inch away from this back wall here. Now, this is another piece, this is another section drawing. You'll notice in this top view, you've got A here, and these arrows point to A, and the line goes along the middle like that. What that's saying is I have a section that's been sliced from A to A. So here's A, and there's A. It's been sliced along this line that is indicated by the A and the A. So if you look at it, if I were to slice it and then turn it, flip it up, look at it from the front, I would see this is where the material's been cut. There's that 1/2 inch hole, it's a simple hole. Here's some more cut material in this area. Right there, that's our counterbore, and our countersink is this one. And then this is another counterbore hole, goes all the way through. So what I want for you guys to do is just like up here on this example, you took the information that you needed to out of here and made a hole note. You took the information out of here and made a hole note. These next 3 slides, A, B, and C, all have necessary information to make hole notes. So your hole notes are going to look like that. You're going to have diameter, number. If it's not through, you're going to have this arrow and the depth. If it's got an extra feature, you're going to have a symbol for that feature, diameter. If it's not, well, it's not going to be through, you're going to have depth if it's a counterbore, or you're going to have the angle like this if it's a countersink. Okay? And last but not least, here's making holes in CAD. And I think what I'm going to do is make this a second video. I just want to get the lecture part out of the way. If you need help with what I want you to do to make these 3, once you've made your hole notes for these, by the way, take a picture of those. Like, just write it on a piece of paper, take a picture of it, and upload that, and then go on to Onshape and build these 3 holes into a block. And my suggestion is you make a block that's 3x4 rectangle and extrudes it to be 2 inches wide or deep, however you want to think about it. So I'm about to start a new video, and when I do that, it'll be the CAD video. All right, y'all have a good one. I'll talk to you soon.